in this video, we're going to talk about like terms and expressions. And I'm going to color code things. So I think you need 6 different colors, maybe just 5. So let me get my colors. 1, 2, 3, 4. I'm not going to write in that green. That one's hard to see. So this pink. And then here's a darker green. Okay, so let's talk about, first of all, the goal of this lesson is to be able to simplify expressions. By combining like terms. And I'm gonna grab my calculator. Okay, so simplifying something means kind of like condensing it, reducing it, making it easier to deal with, easier to look at. So here we have this kind of diagram. We're gonna define each part. Sorry, I have the hiccups. So the first part of an expression, this is an expression. See, it has different pieces, and there's no equal sign, okay? So the first thing we need to know is what a variable is. A variable is and then I'm gonna extra color code, a symbol, usually a letter, let me scooch this down. And we use that holds the place of a number we don't know. So lately we've been using a question mark. We're going to transition to using letters. So X is really common, Y, Z. It could be any letter. Eventually, if you get into like pre-calculus, trigonometry, you'll use Greek letters. It could be any letter. It could be a symbol. You could use a star, whatever. We're going to use letters. We're going to practice that. But it's saying, this is holding the place of a number I don't know. Okay, so I don't have to put a number here, but I can deal with things around it. So in this one, our variable is X, because that's the letter saying 4, I don't know what that number is, okay? So then an exponent tells us how many times to multiply a number by itself. So that is this little 2. It's kind of on that shelf of the X. Sometimes we also call it the power. So to the power of 2, or this one would be squared. Okay. So an example would be 5 to the power of 3 means I'm going to take 5 times itself 3 times. So 5 times 5 times 5 is what 5 to the power of 3 means. 7 squared, or 7 to the exponent of 2, means 7 times 7. So times itself just 2 times. So then the next thing that can be attached to a variable is called a coefficient. And it is the number that is multiplying the variable. It can be positive, it can be negative, it can be a fraction, a decimal, okay? And it's in front of the variable. So here, this means 5 times whatever x squared is. This means 4 times x, right? So this is saying 4 times a number I don't yet know, whatever that would be, okay? So then the last thing that's called a term, the last piece of an expression is called a constant, okay? And it is a number without a variable, so a number by itself, that is being added or subtracted. So 5 is our coefficient, it's multiplying by x squared, x is our variables, the 2 is our exponent, 9 is our constant. It doesn't have a variable, it doesn't have a letter, it's just a number by itself, and it's being subtracted. So we can group like terms, okay? So to be a like term, it has to have the same variable. So it has to have the same letter, so same variable, and exponent. I'm gonna scooch this up a little bit for you. Okay. So even though these both have the same letter, this is an x and this is an x, because this one has an exponent and 4x does not, these two would not be like terms. They have to have the same letter and exponent, or constants are like terms with other constants. So if it has no variable, that's a constant. Those are all like terms. So they have to kind of match. All right, flip to the next page. We're gonna color code some. This is where your colors come in. So we're gonna color things that are like terms the same color. So I'm gonna start with 10x. I'm gonna color it blue. Then I'm gonna find like terms with 10x. It doesn't matter what the coefficient, what that number in front is, as long as it has just an x with no exponent, those are like terms. So 13y, those are different letters. 5y cubed has a letter and an exponent, those don't match. 3x is a like term because it has the same variable. They both have an x and they don't have an exponent. Negative 2x is a like term, same variable, no exponent. Negative 7xy, this one has a y, so it doesn't match. Different letter, doesn't match. This negative 5x squared, even though it has an x, it has an exponent. That does not go with my x by itself. So over here we have negative x. It's an x by itself, negative x. Again, x squared has an exponent. This one's a different letter, different letter. This one has a different exponent. This one has a y. So then there's this x by itself. So all of those are blue. They're all like terms. Okay. You can also like box it, put a star next to it. We'll try that next. Okay. So things that are like terms with 13y. This one has the same variable, but it has an exponent. That's not going to be a like term. This one has a y, but it also has an x. That is not a like term. This one just has a y. So 13y and 8y are like terms because they have the same variable, same letter, no exponent. This one has an x, this one is an x, this one doesn't have a y, this one has an x, x. Again, here's a y, but it has an exponent. That's not going to be a like term. So the last one is this y by itself. Let's circle the next one. All right, so 5y cubed, or to the third power, I need it to have a y and an exponent of 3 to be a like term. So this has a y but no exponent, an x and a y, just an x, no y, xy, So this one has the same variable and the same exponent, so they are like terms. And then that's it for that one. And let's do an arrow for the next one. All right, so negative 7xy. I needed to have both an x and a y stuck together to be a like term. So xy would be a like term because it has the same variables. Negative 14xy would be a like term because it has the same variables. And then this 7xy would be a like term because it has the same variables. Let's do a triangle for the next one. Or color it, whatever makes your heart happy. All right, so the next blank one what we have is negative 5x squared. So I'm going to draw a triangle next to that one. So it needs to have an x as its variable and an exponent of 2 to be a like term. So 4x squared. This one doesn't have a variable. 7 doesn't have a variable. And then 9x squared has an x and an exponent of 2. So those would be like terms. All right, we'll do maybe a box for the last one. So then the ones we have left, negative 10 is a constant. It's a number on its own without a variable. And 7 is a constant. It's a number on its own without a variable. Those two would be like terms. All right. So the next thing we can do is we can combine things and condense them. So here's an example. AJ needs to buy the following things at the store: 2 oranges, 1 loaf of bread, 1 gallon of milk, 3 more oranges, 5 boxes of fish crackers, another gallon of milk, 4 bags of chocolate candies, and 3 bags of licorice candies. So there's some things I can condense here to make this list a little bit shorter. Right, so he has 2 oranges and then 3 more oranges. That's a total of 5 oranges. The next thing is he has 1 loaf of bread. I'm just going to put 1 bread. Then other things we could condense, he's buying 1 gallon of milk, and then he's buying another gallon of milk. So that's 2 total gallons of milk. So 2 milk. Okay, then plus all the other things. This is what combining like terms is. I'm saying, okay, these 2 things are the same. Even though they have different numbers, I can add them together to condense them. So what we did there was we combined things that are alike by adding their amounts. So all of that leading up to this whole point, we're going to identify the like terms, then combine them. You're going to need 3 or 4 colors. Okay. So when we are identifying like terms, don't forget their sign. Okay, we need to include whether it's a plus or minus that goes with that term. And then if a variable doesn't have a coefficient, if it doesn't have a number in front, we're going to use a positive 1. Okay. So simplifying this one, negative 6k plus 12 minus 15x minus k. So this one does not have a number in front, so I'm going to add a 1. That's a minus 1k. Okay. Sorry, just a 1, not a plus 1. Plus 23x plus 8 minus 11x. So I'm going to start by circling the ones that are a k. So we have a minus 6k and a minus 1k. I can combine those by adding or subtracting their coefficients. So I'm going to do a negative 6 minus 1. So this is going to be negative 7k. And the reason I can treat this as subtraction is, remember from our adding subtracting unit, subtracting a positive, you can just add the opposite. So instead of subtracting a positive 1, if I add a negative 1, that minus has to travel with the 1. Then the next one I see are the x's. So this is a minus 15x. That minus goes with the 15. A plus 23x. And then minus 11x. And I can combine those by adding or subtracting their coefficients. So I'm going to do negative 15 plus 23 minus 11. Oops. Okay, which is negative 3x. And then I have some constants, so some numbers on their own without variables. So plus 12 and plus 8 are like terms because they're both constants. 12 plus 8 is a positive 20. So what it looks like to simplify this whole long expression is to group like terms and combine them. And our final answer is negative 7k minus 3x plus 20. All right, last one. I'm going to try to go a little faster. And then we also go in alphabetical order. So I'm going to start with 9n. I'm looking for other terms that have a variable of an n. Here's a minus 12n. And I don't see any others. And my next variable I see is a plus 6t. I use cursive t's because my t's and plus signs look the same. I don't want to get those confused. Then I have some variables of an x, so a plus 8x. This minus belongs to the 2, minus 2x. And then I have some constants, so a plus 15, a minus 4, and a minus 10. I combine them by adding or subtracting their coefficients, so 9 minus 12 is negative 3, so this simplifies to be negative 3n. This isn't combining with anything, so I can just leave it. 8x minus 2x, I'm going to do positive 8 minus 2 is 6x. I'm going to do plus so that I know it's positive. Then I have 15 minus 4 minus 10 is a positive 1. So what it looks like to simplify this is combine their like terms. So these were alike, they had the same variable, they condensed to be negative 3n. I still have to include the plus 6t. These simplified to be plus 6x. And these simplified to be plus 1. Okay, so I can't combine these anymore because they no longer have anything in common. They don't have the same variable, they don't have the same exponent, none of that. All right, so on the back, this one is another coloring to identify like terms. And then this pyramid is to practice combining like terms. So how this one works is you're going to take each box. So I'm going to do negative 2x plus x. So negative 2x plus 1, negative 2 plus 1 is negative 1. Then you can add the constants. 3 plus negative 5 is negative 2. Then I would combine these two boxes to get the one above. So 1x plus 3x will be 4x. Then negative 5 minus 4 is negative 9. So these two boxes combine to make this one. These two boxes combine to make this one. Doop, doop, doop. And then you're going to keep going up till you get to the top.